From our previous lecture, we have learned about how we'll draw a staircase, how we'll complete our model. So in this lecture, I'm going to define and assign load on our structure. First of all, if I show you about our floor plan, so they have a staircase and it's very simple structure. Okay, so first of all, I will define our probable load, which types of load will be applicable in our structure. Then I'll go for assigning that load as per our floor plan. I'll go to our robot to assign load. We have two options. Here you will get option load types. Otherwise, go to load and you'll get a option here load types. So you can click anywhere. I'll click here. First of all, I'll provide dead load. Okay, all types of dead load. In substructure, you will get 4 types of dead load. Dead load, then fluids and earth. Okay, then in our dead load, so first of all, I will take dead load. It will be self weight. Clear? Dead load as a self weight first of all, and this will be dead load, and level will be also dead load. Okay, and our natural will be dead load. Then click add simply. Done. Our dead load as a self weight, we have assigned it. Now we'll go for next load. So what will be the next load? Our next load will be okay, it's DL2, no problem. Then its name will be dead load, let's say floor finish. Okay, so it will be also dead load at then dead load partition wall, dead load partition all, and it will be dead load also dead load. Then click add, even number 3. Then our almost all types of dead load we have assigned here. Now we'll go for live load. Okay, so for live load we have 2 types of live load. One live load is live load floor live load. Then I'll change from here live load, and it's unreducible live load. Then live load floor. Here its name will be, let's say, live load. Okay, then click here or live load, let's 4, live load 4 or live load 1, it's up to you. Then click here add, then live load roof LLR. I will add it on live load. Otherwise you can go for snow load, and here you will get live load roof. Clear? It's up to you actually. So it's better use this load as a live load roof, and it's live load also add LLR live load roof. Then I'll provide another load that will be live load water W, live load water. So water load, I'll assign water load as a live load also. Okay, then it will be live load directly, and it's unreducible live load water. There, so it's done. Our all types of load have been assigned here. Now I will assign wind load and earthquake load. Earthquake X, it will be seismic, or level will be UQ earthquake, and seismic add, then earthquake Y, then wind load X, sorry, I'll delete it. I have to change here wind load X, and it will be W. Okay, So wind, then w wy wy. Okay, wind. So all types of load we have defined. Then I'll close it. So now we are set to assign this load on our structure. First of all, I will assign load on our grade beam. I'll come here. So in our grade beam, all of that free portion will be placed, or if we place any slab here, then it will be placed over the soil. So only the grade beam will carry load from walls. Okay, so I'll consider that a 10-inch wall will be placed over the beam. So what will be the value of that wall, weight of this wall? So I will use an Excel sheet here, design parameters Excel sheet. You will get this Excel sheet with this course. So go to description to find it. Now here I just to calculate load per feet, only I need height of the wall. So as we have considered, our grade beam will be 18-inch depth, so our total height is 10 feet. From there 1.5 feet, 1.25, as this is 15-inch, that means 1.25 feet. So equal to 10 minus 1.25, that means 8.75. Here height of the wall will be 8.75, and thickness, as we have considered, our thickness will be 10-inch, so height will be 875 lb per feet. And if we convert it to divided by 1000, so 0.875 kip per feet. Okay, so 0.875. So I will provide our, yes, I'll save this model. So I'll provide partitional load as a distributed load here. So to do it, click here, load definition, otherwise click here, load definition. It's up to you. I'll click here, load definition. Now from load definition, first of all, we'll go to view, then I'll change it as a dead load self weight, dead load self weight, and here self weight and mass, and they have option whole structure. See, self weight minus pz for whole structure, and I'll click apply. Okay, I'll click apply, done. So when I will take this load, it will act as a self weight load. Then I'll go for another load. We'll go to load definition, go to load definition. You can see the self weight here, the dead load self weight, it's acting as a minus pz load, and it's showing at that in whole structure it's acting. If I change it to floor finish, you'll see they have option dead load floor finish, but model are not changing. That means this load is not applicable here. So what we'll do, I'll go for the next load. Our next load is dead load floor finish. So sorry, I'll go to plan view or grade beam level. Now I'll go to partitional first for our grade beam. Partitional, here they have option member load and distributed load. I'll click here, and our distributed load will be minus 0.875. okay, and it will be in global jet direction. Click add, and simply click on FD beam here available. Just simply click apply, then click here. do it carefully. Okay, so actually this load are not showing here. I'll go here, view, then display, and loads, and plus it. I want to see all types of load. Click apply, close. So here you can see on every in this beam we didn't apply. Click apply, and hope, sorry, here it would that it did not apply, and all that in every beam we have assigned this load. See, on every beam we have assigned. Clear? Take it. Okay, done. We have assigned that load on every beam. Now we'll go for our in our grade beam. Further no load is needed here, and if you think that your slab will be placed over the beam, and you will cast this, or you will cast it monolithically. So basically in grade beam we don't do it. And if you think that sometime our worker do these types of work, that they after creating our grade beam, they placed our all river over the beam and then they cast at a time. So in that time your say load from slab will be transferred to beam, and then you have to calculate it. Okay, so our grade beam load on our grade beam is okay. Now we'll go for next step. So I'll go to our Studio 1. So in our Studio 1, one by one we will start assigning loads. First of all, I'll go for floor finish. In floor finish, previously I have discussed that for every every 1 inch thickness of our floor finish, we will provide 12.5 pounds per square feet, load per square feet. Okay, so over 1 square feet area we have to provide 12.5 pound load. So I am considering that our total floor finish thickness will be 2 inch, let's say. So I will provide this value as a 25 lb per square feet. So this load will be surface load, and I will use this option, and here this value will be minus 0.025, right? 0.025, and it's okay, minus 0.025. Click add, apply, and select the member where you want to assign. On every member I will assign this load. Okay, here also I'll go to 3D, assign here. Okay, in 3D this load are not showing, so to see it again, go view, display, then load. In 3D also assign this option, apply. So here you can see this load are showing. Also here, sorry, load definition, surface load, it's already given 0.0325, then add, apply, and here, done. Now I'll provide here and also here. And one thing, if you unlock this option to or if you do not want to see the bottom face when you are in first floor or anywhere, then you will not be able to assign load here directly. So I request you to by clicking here, do not stop this option. Okay, just see whole structure when you are assigning load. Simply click here. See, everywhere we have assigned this load perfectly. We have no member where we didn't provide the load. Again, I'll go to plan view, for first story. Then I'll change the load here as a partition all load. Okay, before partition all load, I will assign our live.floor. So I'll go to live.floor, then I'll go here, and our live load will be as per code. You have to decide your live load. So for my case, our live load will be 0.4. That means I'll provide 40 PSF load over the slab. So here it's done, and live load, it should be live.floor. It's 0.04 minus 0.04. Add, apply, and click all slab except a staircase. Done. We have assigned AB here. Now we'll go for a staircase. To assign load on a staircase, I'll go to 3D view, and our load will be for a staircase. I'll provide 100 PSF load as per our code. I'll click add, then I'll click apply. I'll click. Okay, I'll change it. Live load floor, and from here we're seeing almost every panel. Let's see. Let's click here, and you can see this value 0.1, 1, 1, 1, 1. That's it. How easy we have assigned this load actually. So now we'll go for our next step. So what is the next step? I'll go for we have assigned partitional load or other load. Now we have another load. What is that load actually? In a staircase, we have provided a self weight. It's fine, but also we have to provide another load here that is not a self weight. So what is the load actually? That load is a weight of a riser and a step. Okay, that is the extension part of our staircase or over the slab. So I'll provide it here, and I have calculated it. Its value is almost 0. Or this value is almost actually 31 or 32 PSF. Okay, if you provide around 10-inch height of your 6-inch height of your riser and 10-inch of your step. So what I'll do, I'll go for it, and I'll provide that as a let's say for that we need to add another load. Or if I consider, okay, if I consider this one, and over dead load, if I go for this one, and here I'll provide 0.03, sorry, 0.03, and click add, click apply. Our self weight will be available when we'll already we have provided self weight, and over that self weight also I'll provide here this two load. I'll click here. Also you can see in that case we have provided self weight also, and also we have provided loads, I mean keep per square feet, and here also. That's it. Only the two member I have to provide these types of load. Now we are all set. Now we'll go for next step. So what will be the next step? Next step will be our partitional load. So if we provide partitional load, then we are ready to replicate our model. So I'll go for partitional load. So I'll click here for partition all load, or I'll go to plan view. Okay, and from here I'll change it partitional load. So here we'll start providing our partitional load. To provide partitional load, I have to go to our floor plan. So in our floor plan, first of all, we have to see in which beam or over which beam we have partition all. So I can see on that beam, on that beam, on that beam, also on that beam, and here on that beam, here on that beam they have a little partition wall from that point to that point, and over this beam no partition wall is available, and they have a partition wall here also. Okay, so we have to provide the partition wall load here. We have to provide partition wall load here first, then we have to provide our another load. Let's say they have a load only on all is available here over this slab. So I will calculate this slab length and I'll find out its weight. After that I will provide this load as a floor load. I'll calculate total load, then I'll divide it by slab area, then I'll find out load per square feet actually as a slab area. Okay, so we'll go for it now. To do it, what we'll do, I'll go first for assigning our line load. Okay. So what will be the value? Our height will be almost 8.75 feet, right? And thickness of this wall is 6 inches almost. So I'll go to Excel sheet, and here height is okay, and I'll provide here 6 inches. So our value will be 525, 0.525 key per feet, 525. Okay, so I'll go here, partition all, dead load partition all. Now I'll go here, member load, click here, 525 minus 525, then click add, and you can see selected type is uniform load over dead load partition all. So I'll click apply here on that beam, very carefully do it on that beam, and on that beam we have load here also. Again I'll go to floor plan, in that beam they have an opening, but I will also provide here, no problem. Also on that beam and also on that beam. So this and this, that's 3 beam. I'll come here, and here. Done. Now I'll go for another load, or I'll go for another partition load that will be applied it as a area load. Okay, so when we are here, and let's say if we surface load, and here I will add surface load. So how will calculate the surface load? Actually, to calculate surface load, I will use this Excel sheet. So first of all, we have to find out the length of the wall. So what is the length of the wall? Then height of the wall. So our height will be 0.875 almost. Okay, and you have to just calculate it like that. Then thickness. So what will be the thickness of your thickness is 6 inches. It's okay. And slab area, we have to provide the slab area actually. Okay, so now we'll do it. First of all, we have to find out our all length. So from here to close it, here to here it's 7 feet and 10 inches, and I will consider till this point because they have a door, so our slab also will carry this load. So from this point to this point, almost here, so 10 feet 10 inches, that means let's say 11 feet total length. And they have a slab, I'll delete it. They have a slab, so let's say I will draw that slab area from, let's say, this point to almost till this point. This is the slab, so I'll consider this slab area. I'll right click here, and this is the slab area 169. I'll put it here 169, and our so the height will be same as previous, and this length will be, let's say, 11 feet. So if I provide 11 feet, 8.5 and 6 inch, 8.75, 6 inch, here we have to calculate this load now. So here our total load will be 34.1716, let's say 34 psf. 34 psf. So how we have calculated that? Simply we have found this volume, okay, length, width and thickness, multiplying this value, then for this 6 inch I have to convert it as a feet, so it will be 0.5. if I divided it by 12, then 11 into 8.75 into 0.5 into 120 as a unit weight of brick wall. Okay, for your case you can change and set it as per your code. Then I'll divide it, that total load, with the slab area. That's it. So 341716 done. 341716. And then when it's done, so when it's done, now we'll go for our next step, that I will assign this load 34. Okay, so how will go? I will go to our software, yes, and to save, and it will be 34 0.34. Then click add and then click apply. You can see here this load is now uniform, and for that slab I will assign this load. It's done. It's showing 0.0. Actually, why it's showing 0.03? Because we have set the limit of that value as a 0. I mean, after 2 digit we'll consider it. So if for your case you can consider it for 3 digit, 4 digit, already we have discussed in our previous lecture. So now I'll go for the next one. So for this slab, let's see, they have also a load available. So what I'll do, I'll take its total length. It's almost 15 feet. So for that 15 feet, and our slab area will be till this point also. Okay, this will be the slab boundary. I'll right click 15 feet and our area will be 176. I'll put it here 176, and our 15 feet, it's 44.74. 0. So as this value are showing after 2 digit of point, now I'll change it actually. So to change it, I'll click here, then unit and format, or by clicking here, you can directly go there, unit and format. And for dimension, let's say after every point we are getting 0.2 digit. So for your case, if you want to change it, you can change it. I will only go for forces right now. So here, see, for forces it's 0.21. I'll go for 3 digit, and here also I'll go for 3 digit, and here also I'll go for 3 digit, or for your case you can go for 4 digit also. Okay, 4 digit. Or what I can do, we can change it to pound. By clicking here, we can change it to lb feet. Okay, I think it's also a good way to change it. And then I can convert it to P3. Then others, they have many things. You can change it as per your requirement. Mass, then weight, I'll go for 3. Okay, and unit edition. So now I'll click okay. Now see, our provided value are in feet, and here we are seeing these values 34 as we have provided 0.034 right now it's okay. So what I can do, I can it's okay for our case, it's okay right now. And also if you want to change it little bit, for forces, let's say after our force, for our force and moment, it's okay. For 1 digit it's okay, I think so. Then click okay. Okay, right now we'll go for this point. For we have provided load for this slab, and we'll go for our next load. So what will be our next load? Our next load will be I'll check it. So here 34, and for this panel we didn't apply. So what will be the value? So in our Excel we'll provide this values 44.74, that means 45. So I'll come here, I will go here, and it will be minus 45, then add, then apply, and it's 45. Now I'll go for this panel. Here we have a wall here, we have also wall here. So I'll calculate it from this point to this point. This is 8, 10, and here almost 8, 4. So 8 plus 8, 16, 17. So our all length will be 17, and here also they have a little wall, so it will be 1 feet, let's say 18. And what will be the slab area till this point? So we'll click on it, and this will be our slab area almost. So 17, let's say our total length will be 18 feet, and our total wall will be 153. So I'll go to Excel sheet. It will be 18 feet, 153. It's 61.76, that means 62. Here I'll provide 62 minus 62, then add, apply, and click here. That's it. So in this way, actually, for every slab panel you have to do. But for our case, we have no more times to do for every steps. I will pause our video and I will complete it. Let's see, we have defined all of our required load over the structure. Okay, so now we are all set, and we'll go for our next step. So what will be the next step? Our next step will be replicating this model, and then we'll go for earthquake analysis and earthquake application and wheel load application. So till next lecture, please watch our previous lecture if you're new here, and till in our next lecture we'll go for replicating our model, and then we'll assign our different types of load also which are required, and we'll modify our roof, and there we have to modify our some load. So thank you very much. Stay connected till next lecture.